seeing these two examples that we did with crazy numbers will hopefully help you understand the steps as we go through them for elimination. Okay? Step 1, simplify the equations and write them over top of each other so that everything is lined up. And it says sometimes you like general form for this, or we wrote them as x's first, then the y's, and the numbers on the other side. Ax plus by equals c. Then step 2, we want to have two of them have the same number in front, but one positive, one negative. Sometimes you only have to multiply one equation to do that. Sometimes you have to multiply both equations to do that. And sometimes, like in the first one, it was already done. Hey, the 46s are the same. One is positive, one is negative. I can just add the equations together. Which is step 3. Once they're the same, add the equations together to eliminate one of the variables. Then you can solve that. Whatever's left, it's easy to solve for. And then from there, everything is the same as the substitution technique. Once you've found either x or y, then you can plug it back into the other equation to see if it would work. I should have, I forgot. You know how I always tell you, take 3 seconds to do the mental math and try to figure it out on your own? I didn't do that with that one. Hopefully you can see why I didn't do that on that one. Mental math-wise, guessing and checking, can you see that would take forever with those big numbers? So we do need a technique. And so this is the elimination technique. And once again, we write our solution as an ordered pair, and we check it. Plug it back into the original one, see if it works. So, can you add these two together? Yes. What will eliminate if we do? The y's, because x plus x, that will be 2x. Y plus negative y, that will eliminate and give you 0. And then 5 plus 7 is 12. Divide both sides by 2. Divide this side by 2, this side by 2, because we want to get x by itself. And we get x equals 6. You can choose either one to solve for y. Let's say I choose, right, I should label these. This is my equation 1. This is my equation 2. If I go to equation 1 and I plug in 6 for x, I could subtract 6 on both sides to get y. So looking at the answer, I could say this one would have worked nice solving with a graph. Right? You could have changed both equation 1 and equation 2 to y equals mx plus b form, drawn the y-intercept, used the slope, found a bunch of points, and you would have found that they intersect at 6, negative 1. Can you imagine doing that work? Okay? Kind of annoying, right? You need graph paper. It would changing the forms. Can you think about the substitution technique? Would it be hard to get a variable by itself? No, easy. Either x or y. Both of them would be really easy to get by themselves, and you could substitute into the other equation. This wouldn't be hard using substitution technique, and you would have got the same answer. Substitution technique, I think, would have been quicker than graphing. And finally, we've used the elimination technique. Things lined up really nicely in this one to use the elimination technique. Okay? right? And some of you, after seeing this example, are like, ooh, this is my new favorite method, okay? Elimination technique doesn't always work because sometimes things don't eliminate. I know, okay? But for what we're doing, you can always, like with 2 lines, you could always use the elimination technique. Let's look at another example. I'll call this equation 1, and this equation 2. They don't match up this time. So then, if nothing matches up, you have to make a decision which one you'd like to eliminate. Because we can choose here to eliminate the y's or eliminate the x's. And both will work. So it really doesn't matter, other than you can sort of predict what the mental map would look like. Okay? Can you see if I wanted to eliminate the x's, I could multiply this one by 3 to get 6, and this one by -2 to get -6. Then they would eliminate. I could also get rid of my y's. I can multiply this 3 by 5, and the -5 by 3. Then I would have 15 and -15. They would eliminate. I would say they're both they both have about the same amount of work to do. The nice thing about canceling the x's is I'm multiplying by smaller numbers. 2 and 3 are smaller than 3 and 5. Not much smaller, but a little bit smaller. The negative thing about the multiplying to get rid of the x's is that if I got rid of the x's, I'd have to multiply one of the equations by -2. And when I multiply by a negative, and using negative numbers just increases your chances of making a mental math mistake. People make more mistakes with negative numbers than they do with positive numbers. Okay? Right? Here we can do an example. I need a volunteer to do some adding for me. Who wants to do some adding? It's not going to be super crazy. Okay? No? First one's 8 plus 6. That's how hard they're going to be. 8 plus 6? 14. -8 plus -3? Okay. So that's all I wanted. He got them both right. Which one took longer? The negative one. So sometimes using negatives can cause more problems. So if I looked at this one, I'm going to multiply equation 1 by 5, equation 2 by 3. I'm not using any negative numbers. Chances are I'll make less mistakes. If I do that, can you see that equation 1 is now 10x plus 15y minus 40 equals 0. I'm not multiplying. If I want to do the x's, right, but we like to have one being positive and one being negative, so when we add them together, they go away. There's also people that use elimination with subtracting. It works the same way as with adding. But people make more mistakes with subtracting. So ideally, we like to add because we make less mistakes. Ideally, we like to use positive numbers because we make less mistakes. So when I multiply this one by 3, the blue one, I get 9x minus 15y plus 21 equals 0. And now I have succeeded in the y column of having the same number, but one is positive, one is negative. When I add them together, 10x plus 9x, 19x. 15y plus negative 15y, that's going to be 0. And negative 40 plus 21 is negative 19. The equal sign will still be in the same spot. And then, to test your mental math abilities, on the other side of the equal sign, you have to add 0. counter to some people who believe that 0 plus 0 via mathematical proof is equal to 8. Because if you have 0 and you add another 0, you get 8 every single time. That's solid logic?
That makes sense.
There we go. So 0 plus 0 is 8. Well, infinity's kind of I drop plus I drop.
It's like you twist it, twist it.
Technical.
Okay, but we will go with the slightly less accepted mathematics of 0 plus 0 is 0. Now we have to solve for x. Well, I want to get x by itself. I'm going to add the 19 to both sides. Whoops. Add the 19 to both sides, right? And then I would like to divide both sides by 19. It got scary there with the 19, right? You're like, oh, is this going to be a not nice number? But x is equal to 1. And now we can use either equation 1 or equation 2. Equation 1, sure. So equation 1 was 2 times x, so now I can go 2 times 1 plus 3 times y minus 0 plus 0 equals 0. And we can solve. Well, 2 minus 8, this would be, oops, we'll stay green, 3y. These are like terms. I get minus 6 equals 0. If I was solving for y, I should add 6 to both sides. And then divide both sides by 3. I can now write my solution as a point. The x coordinate was 1, the y coordinate was 2. There's my solution. Once I have a solution, I can go back to both my original equations and check it. Can I scroll up or not yet?
Yes.
Yes? Everybody ready for me to scroll up? So solution is 1, 2. Check the first one. Is 2 plus 6 minus 8 equal to 0? Yes. Check the second one. Is 3. Oh, x was what? X was 1?
Yeah.
3 minus 10, negative 7, plus 7 equal to 0? Yes. Okay. Excellent. So this was elimination. The most difficult it gets for elimination because you had to multiply both equations by something. But when I look at substitution in this case, can you see that substitution gives you fractions no matter if you try to get the x by itself or the y by itself, no matter which equation you choose. So here the elimination helps us avoid some fractions while solving. Okay? We have to use a negative in this one. Should we eliminate x's or eliminate y's? X, y? I mean, yes. Not y as in y, but y as in y. Because they're easier numbers. I'm going to make this equation 1 in green, this equation 2 in blue. I'm going to multiply by 2, and this one by negative 5. So then I can rewrite equation 1. It will now be 10x plus 14y equals negative 30. And equation 2 will be negative 10x minus 45y equals positive 30. Ooh. When I add those together, my x's, I would get 0 x's, and then here, 14 minus 45 would be negative 31 y's, and negative 30 plus 30? 0. Oh, not too bad. So if I wanted to solve for y, I would have to divide both sides by negative 31. What is 0? Divide by negative 31. 0. Excellent. So we've now solved for y. I can now use equation number 1 or equation number 2 to find x. Going to use 1? Okay, I'll change to green then. 5x plus 7. We can now plug in 0 for y equals negative 15. So we basically have 5x equals negative 15. If I wanted to solve for this, I would have to divide both sides by 5. And my solution would be negative 3, comma, 0. Oh, I should circle my x too. I like that. Can I scroll up? Are we ready to check? Let's do some mental math. If you plug in negative 3 for x and 0 for y, does equation 1 work? Yes. If you plug in negative 3 for x and 0 for y, does equation 2 work?
Yes.
Perfect. Wonderful. Life is good. Until the next part? What does it say at the bottom of the page? The bottom of the page says, congratulations. Oh, we have one more. Oh, we have one more. Fractions. Okay? Substitution could work quite easily in this one, because you could get a variable by itself. You might want to choose that, but we do have fractions. Okay? One thing you can do with any equation that has fractions is multiply to get rid of the fractions. So for example, I could say this is equation 1, this is equation 2. As preliminary work, I could take equation 1. What could I do to get rid of all fractions in equation 1? Times by 2. So even though I'm not even setting things up yet for elimination, I'm just like, I don't want the fractions. I'm going to start by not having fractions. If I start by not having fractions, if I multiply by 2, p over 2 will just become p. Q will become 2q, and negative 4 will become negative 8. This is my new equation 1. It's exactly the same as my old equation 1, but without fractions. Equation number 2, I could times it by 3. That would give me 3p minus 2q, oh my goodness, equals 24. That's my new equation number 2. I didn't think it would work out this nicely. Just, usually you get rid of the fractions and then you would still have work to do. But now we've gotten rid of the fractions. Can you see that we could add right away? There goes the q. P plus 3p. 4p. This will be plus 0. And then 24 minus 8. 16. Divide both sides by 4. and we get P equals 4. When solving for Q, you can plug it into any equation in any form. Even with a fraction, you're okay with it? Okay. So we're saying, people are saying they like to use equation 1, and you could either use this equation 1 or this equation 1. The second one? Okay. If I use the second one, I would have 4 plus 2Q equals -8.
No, 4 over 2.
Some people want to use the other equation 1, 4 over 2 plus Q equals -4. Yes.
Can I use your charger?
Yes. Not a problem. Now, either one, let's say you use this equation 1, well then I would move the 4 over it, and you see that you would get 2Q equals -12, because you would subtract 4 on both sides. Then divide by 2, and you would get Q equals -6. If you use the other one, you would first have to do 4 divided by 2, which is 2. You would have to move the 2 over to the other side by subtracting 2. Whoops. Something miraculous happened on the other side. 4 stays 4. And you would get Q is equal to -6, which is the same either way. Our solution, which is P first, then Q. Sometimes if it's not X and Y, in my solution, I like write my coordinate first with the variables, just to remind someone that P is first, then Q, right? If all of a sudden your alphabet fails you, you don't know which letter comes first. Okay, mental math, let's double check it with the original equations. Does it work? Does it work in equation 1? Yes. Equation number 2, this is a little bit trickier.
Yes.
It does work as well. So our solution is correct. With the fractions, this idea of multiplying by 2 and by 3 would actually be nice whether you are using elimination or substitution. Can you see that doing this, I could still get P by itself quite easily for substitution technique. And then when I plug it into the other equation, I have no fractions. So multiplying to get rid of the fractions in an equation is a good strategy for either substitution or elimination. Probably the only place that the fractions are still useful is when you're doing the graphing technique, because if you were graphing y equals -1/2 x minus 4, that 1/2 is your rise over run. You can use that. Then a fraction is good. When the fractions with the y-intercept, you're like, oh, then it's not so nice. But the fraction with the slope is perfectly fine. Because technically the top is your rise, the bottom is your run, and then you can solve it from there. So we have some questions out of our textbook there at the end, or you can use the last 25 minutes to study for our test on Monday and start working on your pre-test.